The broadcast is now starting. All attendees are in listen-only mode.
We will be starting this webinar at the top of the hour. And so y'all can continue working on your other screens for a few minutes here, and then I'll call you back to attention. Okay, we are ready to get started on today's Sustainability Essentials webinar. I am Susan Ingalls. I direct Sustainable Furnishings Council. I'm delighted to welcome you all, and especially to welcome Jason Grant as our guest presenter today, talking about wood and forests and climate. We want to hear from all of you as well as from Jason. So when you have questions and comments, please send them in via the chat box on the right-hand side of your screen. We will read your questions at the end of the presentation and respond to them all. To start with, I would like to give you a bit of an introduction to Sustainable Furnishings Council. We were founded about 14 years ago in the fall of 2006. A group of suppliers and manufacturers and retailers and designers and environmental organizations gathered together in the showroom of Hieronymo Cookland, who helped us get started. When we started, our first job was to determine what are best practices for sustainability in the residential furnishings industry, and then to set standards for recognizing exemplary implementation of those practices, and then to start educating industry professionals and beginning to build markets. So that is what we have been up to all these years. We have about 400 member companies. Each of them has made their own public and verifiable commitment to sustainability and to transparency and to continuous improvement. And we support them all in realizing their commitment with guidance and resources and education, and with marketing support. All our members use a member seal, and I hope that you will look for it as you are specifying furnishings products. And I hope that if you're not already a Sustainable Furnishings Council member, you will join us. I also hope that if you're interested in the kinds of things we're talking about today, you'll consider learning more from us, perhaps with Green Leaders, our certificate course. It's a 6-hour and 6 CEU course that gives you the gist of what you need to know to make good recommendations for sustaining a healthy future. So if you're interested, there is more where this is coming from. As you probably understand, sustainability is an umbrella term, and there are many, many issues that fall under this wide umbrella. We tend to be concerned about all of them, and we tend to put our attention at where we can have the most immediate impact. So a lot of our work is to address global warming, for instance, by doing what we can to take care of the forests of the world and to halt deforestation. We're also concerned about all these other issues, and we are mindful that sustainability is about taking care of a triple bottom line, not only caring for the ecosystems on our planet, but also for the communities that depend upon those ecosystems and for the economies that support those communities. So sustainability is about all of these things, and we are doing our best in our work, as you will hear, to address them. Furnishings, in fact, is directly related to many sustainability issues. We are a global manufacturing industry, so are responsible for lots of CO2 emissions, not only in the generation of the electricity used in our factories, but also in all the transportation of materials and products all around the world. A lot of those materials are, of course, wood materials, so we have a large responsibility for halting deforestation. We also have a large responsibility for taking care of indoor air quality, which is frequently compromised by the volatile organic compounds that come out of the adhesives we have used in products and the finishes we have put on most everything. Those VOCs, like formaldehyde, are not the only hazardous chemicals we are responsible for. So we have a lot of concern for raising awareness and eliminating others that we can do without. Many harmful chemicals that are used in making furnishings come in when the textiles are made. The textile production industry is one of the most chemically intensive in the world. And the leather production industry is also very chemically intensive. Chemicals are bad for the consumers that finally have the products in their homes, but chemicals also compromise the health of people, and people are affected with cultivation of fibers as well as with the way forests are managed. So our choices in wood matter a lot there. And finally, we in the furnishings industry are responsible for a lot of landfill waste. A shocking amount of furniture is discarded into our landfills, contributing dramatically to that overcrowding. So we do what we can to address all of these issues with our initiatives, including the What's It Made Of initiative, with which we are particularly concerned to encourage transparency in supply chains and stimulate innovation towards the elimination of this handful of hazardous chemicals that is most commonly found in furnishings products. What's It Made Of also has to do with the wood materials. So we have a wood furniture scorecard that we have been using to assess retailers since 2018, looking at whether the company has a wood sourcing policy, whether it is a robust one, and whether it's being implemented well, and whether the company is doing other things to sustain a healthy future. Jason Grant, today's guest presenter, is our partner in working on this with the National Wildlife Federation. So we will be working with him closely throughout the rest of this season to be assessing retailers for the 2020 assessment. All of this is very important because our planet is in such trouble. Here is a video of climate anomalies that have occurred since the beginning of the Industrial Revolution. What we're looking at here is how weather has been warmer or cooler than usual since 1880. And you will see that it is warmer and warmer and warmer. So it is very important that we do what we can to address the causes of global warming. And we're very pleased to have Jason with us today to talk to us and explain why increased forest protection is key to protecting our climate for future generations. Jason has, for the last 24 years, been a leader in the sustainable forestry and green buildings movement. He is the proprietor of Jason Grant Consulting, where he works with companies and with environmental organizations on policy, on advocacy, on marketing and training, and on compliance. He's a LEED AP and has recognized as expert in ecological forest products and forest certification and forest legality. So he is a very useful resource for us today and in our work in the wood furniture scorecard and going forward. And Jason, I'm just so pleased that you are with us now. Thank you for being here. I'm turning it over to you.
Great. Thanks, Susan. Can you hear me okay?
I can hear you just fine, and I do thank you so much for being with us.
Great. Well, I appreciate it, and thanks to everyone who's joined the presentation today. So I'm just going to jump right in.
Good.
And
so you'll click on your screen anywhere, and then on there you go.
Okay. All right. Great. So we are going to cover a lot of ground in this program, and it includes all the topics listed here. It's so much ground, and there's so much information packed in that I have felt obliged to do something that I really hate to do, and that is read from a script. So my apologies for that. I hope it doesn't detract from the program. And yeah, with that disclaimer, here we go. I don't think it'll be news to anyone on this program that forests are vital for people, wildlife, and a healthy environment. They're home to more plants and animals than any other terrestrial biome. They purify the air we breathe and filter the air we drink. They mitigate flooding by acting as giant sponges, soaking up and gradually releasing rainwater. They build soil and prevent erosion. In short, they are at the heart of the web of life. Advance, please. There we go.
You'll want to make sure your cursor is on the picture when you advance, Jason. Thank you.
On the page. Okay, maybe that's my problem. Okay, thanks. Yeah. So yeah, forests do play a central role in regulating local and regional climates by creating and cycling rainfall, and at a global level, they're one of the keys to solving the climate crisis, both because they store vast quantities of carbon already and because they have the potential to mitigate global warming by drawing down and safely storing a significant portion of the excess carbon dioxide now in the atmosphere. Susan, I'm on the screen and I'm up.
We have made a mistake here. I'll go right back to where we're supposed to be, and you will be able to continue from there. Here we go, right?
Okay. Here we are. And Susan, I'm quick up. There it goes. Okay. Yeah, apologies everybody for the technical difficulties. So, forests are engines of carbon sequestration. Because they breathe in CO2 and exhale oxygen, they're commonly referred to as the lungs of the world. Trees use sunlight to convert CO2 to sugar, which is carbon-based and combines with other ingredients to make wood and grow the tree. The chemical composition of wood is about half carbon that will remain safely socked away until the tree dies or it's cut down and its wood rots or burns. Because trees sequester carbon and store it in wood, its use is commonly seen as a climate solution. Of course, wood is one of the key materials used in making furniture, so the question of the climate impacts of using wood versus alternative materials is an important one for the furniture industry. One of the core rationales behind the promotion of wood use is that substituting wood for non-renewable materials like metal and plastic can reduce a product's embodied carbon. Embodied carbon is calculated by totaling emissions associated with the extraction, manufacture, transport, use, and disposal of a given material. The assumption is that if wood use reduces reliance on materials that are more energy intensive to make, the avoided emissions could be significant. What generally gets left out of considerations of the advantages of wood use, however, is the impact of logging on forest carbon. And much of this program will focus on this critical missing piece, without which the true climate impacts of the production and use of wood products can't be understood. As the name suggests, forest carbon refers to all of the carbon stored in a forest, including what's above ground in live and dead trees and other vegetation, as well as carbon stored below ground in roots and soil. Logging results in losses of forest carbon at all scales, from individual trees to forest stands to entire landscapes. Logging causes a near-term release of much of the carbon stored in trees as roots rot and logging slash, such as branches, leaves, and needles, decomposes or burns. More is lost as the log is processed into wood products, and the downfall rots or is burned for power. Only a fraction of the carbon in a tree is carried through to the end of the processing chain and stored in the wood products used to manufacture furniture and for other purposes. When forest stands are logged, there's a loss of carbon stored in soils as well as vegetation. For those not familiar with the term, a stand is a limited and distinct area of forest that is subjected to a specific set of management techniques. The severity of the carbon loss from logging a forest stand depends on its intensity. Clear cutting results in a greater loss than selective harvesting does. Industrial logging across large areas can be a major source of CO2 emissions, especially when it converts natural forests to intensively managed tree farms. Logging accounts for 85% of emissions from U.S. forests, more than 5 times those from forest conversion, fire, wind, insects, and natural tree mortality combined. In evaluating the embodied carbon of wood relative to other materials, the tool used to calculate and compare cradle-to-grave emissions, life cycle assessment, or LCA, typically does not account for any reductions in forest carbon stores that may be caused by logging. Most LCA studies assume that the impact of logging on forest carbon is neutral, the theory being that in managed forestry, emissions and sequestration are generally in balance. Reliable methods for calculating the impacts of logging on forest carbon and factoring them into LCAs for wood products are being pursued but do not yet exist. The results of LCAs for products are reported in Environmental Product Declarations, or EPDs, and the fact that what happens in the forest is left out of the accounting means that the carbon footprint reported in today's wood EPDs may be inaccurate. Beyond carbon, LCAs and EPDs for wood do not address the actual impacts of logging on all other aspects of forest health, such as wildlife habitat, soil and water quality, etc. And so far, at least, these emissions are not prominently noted in a tool that is touted for its comprehensiveness and transparency. The notion that all wood is forest carbon neutral is a vast oversimplification that ignores the starting condition of the forest prior to logging and the type of forestry practiced. According to one recent study, depending on the assumptions going into calculations of the carbon footprint of wood, current estimates of the benefits of substitution may be greatly exaggerated. While the actual benefits of substitution are uncertain, we know for sure that if younger forests are allowed to grow instead of being cut down, emissions of forest carbon will be kept to a minimum, and they will continue to sequester CO2 in ever larger amounts for a very long time. Recently, scientists have begun referring to this process as pro-forestation, and are elevating it as one of the safest, most effective, and low-cost approaches to climate change mitigation available. Critically, in the next decade, when the window to avoid runaway climate change is most open, protecting more forests will result in far more avoided emissions and carbon removal than will logging them and turning them into wood products. Pro-forestation is even more important as a climate solution than planting new trees, also known as afforestation, because the latter won't make much of a difference in the next couple of decades when action to avert runaway climate change is most crucial. This is because small trees just don't sequester and store all that much carbon. You may have heard that young trees grow faster than older ones, and this is true. But what really matters isn't the rate of carbon removal, but rather the quantity. A 5-year-old sapling grows fast, but it's so little that the amount of wood it adds every year is comparatively small. A 100-year-old tree grows slower than a sapling, but it's much bigger. So a lower growth rate translates into a larger amount of wood added and carbon stored. Old trees store the most carbon. One study found that in natural forests around the world of all types, half of the carbon is stored in the largest 1% of trees. Another frequently heard argument is that mature forests are quote-unquote decadent and stop absorbing carbon, so we should cut them down and plant new trees. It's a fact that as forests age, emissions from tree mortality gradually increase until eventually, when the forest reaches the old growth stage, emissions and sequestration more or less come into balance as the carbon stored in vegetation peaks and plateaus. But when the forest is logged, we lose a lot of that stored carbon in the atmosphere, and it will take a long time to reabsorb it. Since what matters most is avoiding emissions and maximizing carbon removal and storage in the near term, it makes no sense to replace old forests with young tree farms. Doing this creates a carbon debt that will only be recouped if the plantations are left alone for hundreds of years. Now let's change gears and look at how different approaches to forest management can impair or enhance a forest's capacity to remove and store carbon. It's relatively straightforward to visualize how this works at the level of an individual forest stand. This chart represents two different starting conditions. The dark green line is an old-growth forest, and the light green line, an agricultural field where trees are planted. With the old growth, forest carbon starts high and drops steeply when it's logged, while with afforestation, it starts low and builds for several decades. The stand represented here is logged once every 40 years on a sustained yield basis where tree growth and timber removals are in balance. The level of forest carbon drops with each harvest and then builds back up before the pattern repeats. On average, it stays about the same. However, the picture gets more complicated at the landscape level, where numerous stands are being managed simultaneously. Visualize the managed forest as a bucket, and forest carbon as the water inside it. The landscape is made up of multiple stands that have been logged at different times and are in different stages of regrowth. Some are taking up carbon and some are releasing it. The challenge is to determine how all of these offsetting inputs and outputs affect overall carbon stores. And we need to do that to understand the differing effects of different approaches to forest management. As I've noted, carbon stores are highest in old growth forests, also known as primary forests, where there's been no logging. The water in the bucket is at or near the top. This level is never static, however. The bucket has leaks. Trees are constantly dying and rotting, releasing carbon into the atmosphere. But even a leaky bucket can hold water as long as water is being poured into it. At the same time that carbon is being emitted from the forest, it's constantly being absorbed from the atmosphere. As I said before, the amount of water in an old growth bucket will remain fairly constant over time. When the forest is logged, it impacts both the amount coming into the bucket and the amount leaking out, but the larger impact is on the leakiness. The more holes you have and the bigger they are, the leakier the bucket. And the leakier the bucket, the less carbon it will store. In this analogy, the number of holes represents the frequency of logging, and the size of the holes is related to its intensity or severity. The large clear cuts characteristic of conventional industrial forestry can be pictured as bigger leaks, and the relatively frequent harvest can be pictured as more numerous leaks. On the other hand, less intensive logging that occurs less frequently can be pictured as smaller, less numerous ones. As trees regrow after logging, more carbon gradually flows in, less escapes, and the level in the bucket gradually builds back up. But each time logging occurs, the bucket again gets leakier, and the carbon level falls back down. And again, the more intensive and frequent the logging, the farther it will fall and the lower the average level will be. If there's a transition to climate-friendlier forestry, on the other hand, the holes get smaller and less frequent and the bucket becomes less leaky. The average level will build up and remain higher as long as the management system is continued. Forest carbon stores under climate-friendlier forestry regimes are significantly increased. Thus, improving forest management and increasing forest recovery and protection are key to mitigating climate change. The steps we need to take are as follows. First, logging of the world's remaining intact primary forests must cease. Forest carbon stores are highest where there's little or no logging. Therefore, we should permanently protect primary forests, particularly but not limited to those that are the most carbon rich. And in the U.S., these are mostly found on federal forest lands. Second, protection should be extended to allow for pro-forestation of wide areas of previously logged forests, letting them grow back and recover their ecological and carbon storage potential. In some cases, this process of recovery can be speeded through human intervention aimed at true restoration. Where logging continues, it should become less intensive. For example, selective logging or smaller, more widely distributed clear cuts, and higher levels of retention, which is to say leaving more live trees behind after a timber harvest. Another key is lengthening rotations, which is to say the time interval between cuts. Tree plantation should not be established at the expense of natural forest. Because complex forest ecosystems store more carbon than plantations and are more resilient in the face of climate change, many existing plantations should be restored to a more natural condition. And finally, afforestation is desirable because it brings carbon benefits and will increase wood supply in the longer term. But, as has been noted, it takes decades for newly planted trees to achieve the levels of carbon removal and storage that can be realized much more quickly through proforestation and a large-scale transition to climate-friendlier forestry. Reforms such as these would not only improve the management of forest carbon, they would yield numerous other important environmental benefits, including less damage to wildlife habitat, relatively higher ecological complexity and biological diversity, and reduced negative impacts on soil and water quality. As it happens, what is better for carbon is better for all of the other critical ecosystem values and services forests provide. We can't solve the climate crisis without increasing forest protection. What's left of primary forests in the U.S. are largely on federally owned lands where significant but incomplete conservation agreements have secured some protections. We need to protect them completely. And this is why a growing number of people are advocating for the creation of a forest carbon reserve on public lands that would identify and protect carbon-dense primary forests, as well as areas suitable for proforestation, restoration, or afforestation. Along with increased protection on public lands, we need to change our approach to working forests. Climate-friendlier forestry requires a long-term view of forest management and an appreciation for the full array of environmental and social benefits that healthy forests offer. There's a trade-off between maximizing the short-term financial return on managed forests and enhancing the carbon and other environmental benefits of forestry. Unfortunately, our financial system favors quick returns and drives detrimental short-term thinking and practice. Businesses bent on maximizing profit, clear-cut, replant, and log again on short rotations because of the time value of money. Basically, potential future income gets discounted such that $1 today is worth more than $1 tomorrow, and $1 in 50 years is worth a whole lot more than $1 in 100 years. Because the greatest barrier to the uptake of climate-friendlier forestry on private lands is financial, any solutions must shift the economics. There are three main ways to do this. Raise the level of the playing field by strengthening government regulations. Incentivize change through policies that price carbon at a level that makes it financially attractive to forest owners to improve. And third, by rewarding it through the marketplace, such as by buying forest carbon credits or sourcing products certified to relatively high standards. We all have an idea of how government regulations work, but pricing carbon as a way to underwrite improvements in forest stewardship is less widely understood. One way to do this is through a cap-and-trade system. At the most basic level, how this works is you tax polluters and use the proceeds to pay for activities that reduce emissions or remove and store carbon, which can include forest conservation and stewardship. For example, California has a cap-and-trade program that imposes limits on the emissions of the state's largest polluters, such as utilities and large industrial plants. Companies that exceed the cap have to purchase carbon credits, and one place they can go to buy them is a landowner who is practicing climate-friendlier forestry. In order to garner carbon credits for sale, forestry operations have to go through a process to become a registered forest carbon project. This includes making long-term, legally binding commitments to forest management that will result in increased carbon stores over what would happen at the regulatory floor. And the more carbon stored, the more credits you can sell. So you get paid for creating a less leaky, fuller bucket. For example, a decade ago, an organization called the Redwood Forest Foundation purchased 50,000 acres of forest land in Northern California that had been severely damaged and depleted by past logging. They put the land into a conservation easement that protects the forest in perpetuity. Trees must be allowed to grow to 100 years old before they can be cut, and timber harvests are limited to no more than 3% of the total inventory, low enough so the forest will recover, timber volumes will increase, and stores of forest carbon will build up over time. They were able to register and sell credits for over 3 million tons of carbon that accumulated between 2007 and 2014. Forest certification can be another way to incentivize climate-friendlier forestry. Among the available forest certification systems, the FSC, or Forest Stewardship Council, best reflects and supports climate-friendlier forestry. Among other things, FSC standards protect old growth and require less intensive practices than are permitted by law. An environmental organization called EcoTrust recently released a study that compared outcomes under business-as-usual forestry at the regulatory floor with those of FSC-certified forests in Oregon and Washington. EcoTrust found that FSC always stored more carbon, between 25 and 60% more on average. They also found that FSC could increase yields on a per-acre basis, but that this was offset by reduced yields resulting from higher levels of protection. For example, FSC requires wider stream buffers than business as usual in Oregon, taking substantial areas of land out of timber production to protect water quality. Sourcing good wood and supporting climate-friendlier forestry is key, but it's equally important to avoid wood that's tied to forest degradation and destruction, and the very worst wood comes from illegal logging. Is illegal wood being used inadvertently or deliberately in furniture manufacturing? It's actually quite possible because illegal logging is far more pervasive and the trade in illegal wood much larger than most people think. Particularly if you are using woods harvested in developing countries, there's an elevated risk that wood products may be illegal. The U.S. LCAS Act makes it a crime to trade in wood that's been illegally harvested in the country of origin, so being aware of these risks and taking effective steps to mitigate them is very important. An estimated 50 to 90% of all forestry activities in key producer countries in the tropics is illegal. There are also high rates of illegal logging in Russia and parts of Eastern Europe. An estimated 20 to 50% of all timber traded internationally is illegal or high risk. And illegal logging and the associated trade in wood products represents the world's third largest transnational crime, only after counterfeiting and drugs. Illegal logging is a major contributor to deforestation. Loggers build roads into previously inaccessible areas of primary forest, paving the way for conversion by providing access to farmers and ranchers. And forests that have been robbed of their most valuable timber are more likely to be burned and converted to other uses than are unlogged or managed forests. This has major consequences for the climate. Deforestation is one of the largest sources of greenhouse gas emissions, contributing up to 20% of the global total. The problems underlying the illegal wood trade are deep-seated and systemic. Illegal wood gets mixed with legal material toward the top of global supply chains, and once this has happened, it's very hard to detect. Furthermore, current methods most commonly used by law-abiding companies to mitigate the risk of sourcing illegal wood, such as gathering documents or conducting audits, have fundamental weaknesses. Documents are notoriously easy to fake, and auditors who generally pre-schedule their visits can be duped. Even the best forest certification systems are constrained in their ability to effectively screen out illegal wood. Obviously, this state of affairs poses tough challenges for those who don't want to buy illegal wood. How do you avoid what you can't reliably identify? Well, here's an answer. You can support the development of scientific solutions that resist gaming and are being developed by a global network intent on cracking down on forest crime. Some of you may be familiar with the LEED Green Building Rating System, the most widely used certification program for building construction in the world. This is the goal of a new LEED pilot credit that rewards the use of emerging technologies for wood identification and traceability. The experts who designed this credit have pioneered a new cutting-edge approach that we call declare, map, and test. The first step is declare. Suppliers provide declarations identifying the wood species and country of origin for all wood products used on a project. The second step is map. Suppliers provide maps that more precisely identify where the timber was harvested. And the final step is test, using scientific techniques to check the information provided in declarations and maps. At the heart of this approach are testing methods that can identify the species and geographic origin of wood products. If wood suppliers are required to declare this information and to back it up with maps of source forests, then these claims can be scientifically assessed. A hurdle to making this approach work is that wood identification testing can only be used to verify declarations of species or origin if you have reference data against which results can be compared. So for example, testing can detect certain stable isotopes in wood whose ratios vary by geography and can be used to determine origin if georeference samples of that species have been gathered and tested in advance to provide a basis of comparison. An immense effort is now underway to build libraries of reference data, and the furniture industry can send a demand signal that supports their expansion. While by itself, declare, map, and test can't distinguish wood that's legal from what's illegal, it does create a mechanism for holding wood producers and traders accountable. And accountability is key because law-abiding companies will be highly motivated to pass tests, and their upstream suppliers will therefore be under great pressure to provide good information and not look the other way when offered cheap wood that may be illegal. When combined with other approaches, this is a powerful way to fight crime and support the many honest companies in the wood products industry. Now I want to come full circle back to the central question this program set out to address. Is using wood a climate solution? Recently, this question has come to the fore in the construction industry, where there's a growing buzz around mass timber construction, substituting new engineered wood products like cross-laminated timber for steel and concrete in the structures of mid and high-rise buildings. But it's relevant to the furniture industry as well. There's a simplistic narrative out there that goes more or less as follows. Trees suck carbon out of the air that gets stored each time we log timber and use the wood in furniture buildings and elsewhere. We reduce emissions by substituting this wood for other materials. And this process only continues if we keep on logging. The conclusion that follows is that the more we log and the more wood we use, the better off we'll all be. But hopefully by now it's clear that whether or not using wood will help us solve the climate crisis depends entirely on where the wood comes from, where it does not come from, and how it's harvested. Can wood be a climate solution? Definitely. But a significant increase in wood use that's satisfied by an increase in environmentally harmful logging and contributes to forest degradation and deforestation will only deepen our problems. The key question is, will using more wood result in an overall decrease in atmospheric carbon and an increase in carbon stores? And without great advances in forest protection and stewardship, the answer is almost certainly not. In closing, here's some resources for sourcing wood responsibly, promoting climate-friendlier forestry, and avoiding illegal wood. At the beginning, Susan mentioned the Wood Furniture Scorecard, and there's a ton of useful information on this website, including a how-to section that includes detailed guidance on how to develop and implement responsible wood procurement policies, including information on the policies and practices of companies that are leading the industry in this area. FSC has a great website at buildwithfsc.com, including a new wood finder, a tool for connecting with existing suppliers of FSC certified wood products. And there's a whole lot out there about illegal logging, but for those interested in learning more about best practices for avoiding illegal wood, I recommend checking out the Timber Traceability LEED Pilot Credit, or you can contact me. And that's it.
Great. Thank you so much, Jason. I hope people will contact you for more information. This is really a great overview you've given us and very practical information. And as you as I said earlier, our working with you for the Wood Furniture Scorecard makes a huge difference to our industry. So I do want to be sure to mention again that the 2020 Wood Furniture Scorecard, which will be, the results of which will be announced in mid to late summer, the assessments will be going on throughout this coming spring, and we are going to be very pleased to be working with you, Jason, and for you to be working directly with the retailers we're assessing. So I want to turn to the questions we have gotten. Someone asks, what again is the percent of illegal wood coming from overseas sources? I was surprised, Jason, when we were talking last week at how much illegal wood there is. It was more than I was aware of, and your figures are based on what Interpol reports.
Yeah, well, if the question is what percentage of what is the percentage of wood imported into the U.S. is illegal, I would say no one knows. The Interpol figures are for wood traded internationally overall, and we don't know how much of that wood enters the U.S. But what we do know is that a lot of illegal wood finds its way into countries that have very large OEM capacity, such as China, where they manufacture products like furniture, flooring, other products, often under a private label, and then those products get sold in the United States. And so that's the great difficulty, is where you are sourcing manufactured wood products, more value-added wood products from companies, or rather countries where costs are low and cost pressure is very high, and where there aren't necessarily good laws or even ethics for avoiding illegal wood. And in some cases, it's been found, there's been reports and investigations where certain Chinese companies, not just to pick on the Chinese, but they are recognized as being very problematic in this area, where they've been the ones corrupting officials in countries like Africa and driving illegal logging. Mm-hmm. So it's really a risk, I would say, when you're sourcing wood products from certain countries, from certain geographies, and it's very much linked to corruption.
Mm-hmm. Mm-hmm. Yeah. And a couple of statistics you gave in the presentation, which is recorded and will be on our website, is 50 to 90% of logging in the tropics is illegal. And of course, we don't have tropics here in the U.S., so the tropical wood coming into the U.S. would be part of what is risky, as you are describing. Yeah. Okay. Let's see. Here's the question. Are big companies aware of this problem? I think so, Jason, but talk about about awareness and the challenges of actually following a supply chain. This is why having a policy like what we describe on the Wood Furniture Scorecard website is so important.
Yeah, sure. I would say that most large companies that do a big volume in imported wood products are very aware of the problem, and they're concerned about complying with the law, which means they have to comply with the U.S. LACI Act, which is a U.S. law that makes it a crime to trade in illegally logged or traded wood overseas. And so I would say that most companies that have exposure under the law are doing risk mitigation. They have due diligence systems, and they're doing their best to assess and mitigate risk. That said, if you're far down the supply chain, what most people who do this sort of due care, as it's also called, rely on are things like documents and audits. It's sort of the best available tools. And I know this firsthand because one of my clients is a large wood flooring importer and distributor, and I, for several years, have done due diligence for them, and I developed their due diligence system. And this is why I am personally so excited about these developments in science and in wood forensics that will allow a really foolproof check on claims, because you do your best as an importer or retailer, but the fact is it's hard to know, and it's hard to have confidence in documents and even third-party audits, which happen once a year. They're pre-scheduled, and you can bet that if you're a criminal, you know, you're going to be careful at the time when that auditor comes in, and you're going to be careful what you show them. Mm-hmm. So it's just a very tough problem, and even you know, companies that have very robust systems and are doing their very best, there's inherent limitations in what you can do without the science. And so it's just so important over time for these scientific methods to be to develop and to be supported by the industry.
Mm-hmm. And Jason, I know that people are wondering, well, how much would that cost? And I know that probably the more people use the testing, the more efficient it will be for testing to be done. But do you have an idea of costs on that?
Yeah, it depends very much on the type of test that's done. So a very basic, well-established way to identify wood species is through a process called wood anatomy. And that would be a relatively low-cost test, maybe, I don't know, a couple $100. Isotopic testing, which is currently the best available technique for testing for wood origin. Again, it's only possible, it only works where you have georeference samples that you can compare results against. But those do exist for some species. Yeah. And the company that I've been doing LACI Due Care for has been doing isotopic testing for some of the products, and on average per product it costs about $500. I should say per sample. Per sample.
Okay. Thanks for giving us that idea. On the subject of money, here's a question. Can companies be fined by the government if they are sending to the U.S. illegally harvested furnishings? So this refers to LACI.
Yeah. Well, so yeah, the way the LACI Act works is you only face penalties if you get caught, of course, and those only apply to U.S. companies. So it only applies to importers, not producers or exporters. So if you are, actually I should say importers, retailers, anyone in the distribution chain in the U.S. who is caught trading an illegal wood product is exposed to penalties. The level of the penalties varies depending on whether or not the folks in the supply chain exercise due care.
Yeah.
And the degree of due care, the sophistication, how robust the due care system is expected to vary depending on the size and resources of the company.
Mm-hmm.
And so the Lacey Act, they deliberately made the concept of due care very flexible.
Mm-hmm.
And they do not provide definitive guidance on what the companies need to do in order to exercise due diligence. So there's a lot of variability out there, I would say.
Mm-hmm.
But that said, there are many companies that are doing their best. And I would say if you're in the furniture industry and you're using imported wood in your own production, or you're importing furniture from overseas in a high-risk context, you just need to either be doing good due care yourself, or you need to be working with companies that are doing effective due diligence, or you are open to risk. And if they catch you trading in illegal wood and you are practicing good due care in their judgment, then you face forfeiture of the goods.
Mm-hmm.
If you aren't practicing good due care, or heaven forbid, they are able to prove that you knew you were deliberately trading in illegal wood, then you can face very severe civil and criminal penalties.
Mm-hmm.
The big Lacey enforcement action that caught people's attention a few years ago was when Lumber Liquidators was caught trading in illegal flooring from China, wood originating in Russia, and they paid $16 million in fines.
Mm-hmm. Wow, that's big. Yeah. Okay, I have a question here about FSC. You had mentioned that inspectors come on schedule. And the question is, why do they have to schedule inspections? Why can't they just come at a surprise time?
So they could, and actually sometimes FSC's accreditation arm, it's actually a separate organization, but it's connected with FSC. It's called ASI, Accreditation Services International.
Mm-hmm.
They are tasked with certifying the certifiers. So they are the ones who make sure that the certification bodies who go out and do audits are doing a good job.
Mm-hmm.
And ASI has the right to randomly drop in if they suspect that something shady is afoot. But the ones who do the actual audits, the certification bodies, these are private organizations, many nonprofits, some nonprofits. I think we're up to at least 24 globally because FSC is a global system.
Mm-hmm.
And they schedule their audits. And the companies they audit are their clients who pay them for their services. So they do not just show up unannounced. They could theoretically, but it would mean completely changing the model of how certification works. And by the way, this is true not just of FSC, it's true of SFI, it's true of PEFC, it's true of all forest certification.
Mm-hmm. Mm-hmm. That's good to understand. Back to what you were talking about just a little bit ago about wood identification technologies. FSC has sent in a note here with a resource that sounds very interesting. CNN recently covered these technologies, and there's a link to the video on the on CNN. So that was back in late November when that aired, and it would be interesting to all of us who are interested in what you're talking about now. So thanks for that resource about the story on CNN about wood identification technologies. Now let's go back to the carbon topic. Here's the comment. There is a conflict built in here between climate-friendly forestry and carbon storage, which increase the cost of wood products and alternative products that are taking market share from wood. Those alternative products typically emit more carbon. In furniture and flooring, those alternative products include plastics, vinyl, tile, concrete, etc. Any suggestions on how to resolve this conflict? Well, I always say it's a myth that it costs more, but I know sometimes it does. But what do you? Yeah, go on.
That's a really tough question. I don't think there's any easy answers. It actually does cost more to do climate-friendlier forestry in many cases, if not most cases. If it's not higher direct costs, then there are indirect costs like opportunity costs, because you aren't maximizing yield or maximizing the financial yield, even if in some cases you actually get more yield of wood if you manage forests, say, on a longer rotation, but the financially optimal yield is the shorter rotation. You get less wood, but you make the most money using standard techniques for calculating profitability over time. So yeah, I would say that this is a very tough question. There's no easy answer. We have to draw the line somewhere, for sure. And the cheapest wood is illegal wood. Just take it out of the forest. And we don't want that. And so I think it's really a question of how serious are we about tackling the climate crisis? I mean, really, we need carbon taxes and other things that are going to make those energy intensive, high carbon footprint materials more expensive.
Yes.
And really reflect their true costs, and may therefore make wood a more desirable opportunity if it comes from forestry that at the very least maintains carbon neutrality where you don't erode carbon stores, but ideally supports forestry where you build carbon stores.
Yeah, you're right. Legislation is going to make a huge difference, and using our heads as we source materials, especially wood materials, and thinking about the broad picture. We haven't discussed urban woods, but one of the things I thought about as you were talking, Jason, was one good way to take care of forests is to use to recycle and reclaim wood that is already out of a forest. And that, I think, could make a difference too.
It's the best way. I mean, that's going to be your lowest carbon footprint wood product, is one that's reclaimed.
Yeah, and we've got a lot of it to reclaim. Jason, thank you so much for all this excellent information. And thank you to everyone who's been with us this hour for your attention. I do hope that you'll stay involved with us, that you'll get further involved, especially in our wood furniture scorecard and in other aspects of our work. And I hope you'll join us again next month for the February webinar. Thank you again, Jason, and everybody.